In lesson 85, we're going to talk about systems of nonlinear equations. That means we're going to have at least one equation that is not linear, that's not a line. So we'll have at least one thing that is a parabola. We've been drawing some of those. Or at least one thing that's a circle, or that's a cubic, or a hyperbola, something besides a line. Might have one line with one thing that's not a line, or we might have two things and neither one is a line. Those would all be linear systems, or it would be nonlinear systems. So we're not doing the ones right now with any graphing, so no calculators on this. I am, though, going to do just this first one with a picture to kind of let us get an idea of what's going on, and then I'll go to the next slide and do this with just algebra. So first one, is that a line? X squared plus y squared is 25. How do we know it's not a line? Emily? So what are you seeing that's making you think of that? What? So you're seeing the squares in there, which definitely mean that it is not going to be a line. Now, wait a minute. Our parabolas have had the x squares in there. Could this be a parabola? Or is there something in there that lets you know it can't be a parabola? What doesn't look quite right, Abby? Yeah, both of them are squared. We're used to y is not squared and x is squared, and then it's a parabola, but this one has both of them squared. What this one is actually going to be, and you'll learn how to recognize this down the road, this one is actually going to be a circle with radius of 5 and centered at the origin. So this is at least close to the right size. So it's about like that. What about the second one? Is it also a circle? Do you know what it's going to look like? Is it a parabola? Is it what do we think about the second one, Cooper? And why do you think it's going to be a line? Yeah, there's no squares. Could we get it y equals mx plus b? So we could even draw that in real fast if we wanted to. We could say that's going to give us what y is negative 2x plus 5. So it looks like I need a y-intercept of 5 and a slope of negative 2. So it's got to go through here and have this slope. And I hit the wrong spot there to make that become a line. Okay, let's try this now. So slope of negative 2. So I think it's kind of looking something kind of like that. And I'll stretch it up this way a little bit. So kind of sort of like that. Okay, we know that when we're solving systems, we're looking for what points are on the line and also on the circle. So how many solution points do we have on this? How many places are there where they cross? Kit, why are you holding up two fingers? So we've got 2 points on here. So that point is going to be one solution, and this point is going to be another solution, and we need to find it. This one we probably could count boxes and figure it out, but most of the time that's not going to be an option with these kinds of problems. So let's just jump in and do this algebraically. Same circle, same line. I'm telling you, we're not doing this graphing. We're not putting it on the calculator. We're not having the calculator find the intersections for us. So what other methods do you know for solving systems of equations besides graphing? What, Abby? Substitution or elimination. So you think, might we be able to give either one of those a try here? Leah, which one are you thinking we might try on this? And what would you do for your substitution? Okay, so take this one and get y by itself as either negative 2x plus 5 or 5 minus 2x. And then we're going to put that in for this y. Thumbs up, thumbs down. Are we good with that? Okay, so let's then, we're putting it into this top one now. So we've got x squared plus, and instead of y times y, I now have 5 minus 2x times 5 minus 2x equals 25. So everybody see that all we've done is substitute. Now this 5 minus 2x squared means we've got 5 minus 2x times 5 minus 2x that we have to FOIL out. So we keep this first x squared. And Jack, would you help me FOIL the 5 minus 2x times 5 minus 2x? Tell me what I should write down here. I'm not sure why you start on the right, but keep going. Then minus what? Okay, so let me turn that around to the usual left to right order that most of us are used to seeing and thinking about that on. We take the first times first, 5 times 5 is 25. Then we've got a minus 10x and another minus 10x to make minus 20x. I think you actually said minus 20 and I just wrote it down wrong. And then minus 2x times minus 2x minus minus would be plus. The 2 times 2 would be 4. And the x times x would be x squared. So are we good with that? Does that look right to everybody? Give me thumbs up. Check us now. Okay, and then that equals 25. Let's see if we can clean that up, combine terms, get things where we can work with it. So Yo-Yo, would you help me clean it up some? Okay, so putting those two together, you get a 5x squared and minus the 20x plus 25 equals 25. So if we subtract the 25 on both sides, let's say it equals 0. So everybody okay? Okay, I've got a quadratic equation. How should I solve this quadratic equation now? 5x squared minus 20x equals 0. I know how to solve quadratics using algebra. If I factor, complete the square, quadratic formula, what's going to be the easiest way to do this, do you think? What's an easier way to do this? Caleb, what do you think? I could do the quadratic formula, but I personally think there's an easier way. Quadratic formula would work with A is 5, B is minus 20, and C is 0. Anybody see an easier way? Griff? So everybody good with, hey, if we can factor, we always want to look for a GCF first. 5x, and that leaves us x minus 4. What do you think? Is that easier than quadratic formula? So what solutions do I have now? Ada? And? 5x is 0, gives us x is 0. X minus 4 is 0, gives us x is 4. Okay, are those my solutions? It's getting me closer, but remember, my solutions need to be 2 points for this. And all I've got is 2 numbers. I don't have points yet. Am I saying that one of those points is 0, 4? Because both of those say x equals. What this tells me is that one of my points is 0 comma something, and the other one is 4 comma something. X's are 0 and 4, so I had to put those in the x spots in these points. Now, this is not interchangeable. If x is 0, I am going to go back to my equation here and say if x is 0, I have 2 times 0 plus y is 5. So what is y, everybody? So that said, if the x is 0, the y has to be 5. If the x is 0, it cannot have anything different for a y. Then I do it with the other one. If x is 4, I plug that into this same equation. Then I have 2 times 4 plus y has to be 5. 2 times 4 is 8, so subtract 8. And what is y, everybody? This says if the x is 4, the only thing y can be is -3. I can't have 0, -3. I can't just write I can't just write it any old way. I have to say that the 0 for x goes with 5 for the y. I have to write it as an ordered pair. Let's go back to our picture. 0, 5, 4, what do we say, -3. Does that more or less make sense for our picture? Although it looks like I've kind of got my graph a little bit off with that, but does that kind of make sense if my graph were a little bit more accurate? And that's what's going on. Normally you don't draw the picture. I just want to do that on one to help our brains kind of make connections here. Okay, let's do one more, very much like this, but no graph. Top one's a circle, but it's not as nice. Now it's got a radius of square root of 13. So you can see right away it's not as nice. And a different line. So how should I start out, Yesenia? Well, what substitution can I do? Or 2y minus 4. This time I've got x equals, so I'm going to put that in for this x. So I am going to have 2y minus 4 times 2y minus 4 plus y squared is 13. So Nicole, would you help me FOIL my parentheses? So 2y times 2y is 4y squared. Then we would have the minus 8y and another minus 8y to give us minus 16y. And finally, minus 4 times minus 4 would be plus 16. And then we have our other y squared here, and it equals 13. So Wyatt, help me put terms together, please. Well, give me the y's on the right, or on the left. Okay, now, when we're factoring using quadratic formula, we need things equal 0, right? So let's get everything on the left. So if we subtract the 13 on both sides, a plus 3 equals 0. So we have a quadratic equals 0. We could use our quadratic formula, but then when we do square root of b squared, we've got to deal with a 16 squared, and I'm saying no calculators on this one. So I don't know if I really want to mess with numbers like that. I could complete the square, but then I'd have to divide everything by 5, and so I'd be dealing with some kind of messy fractions. Or I could try to factor this. It does not start with 1y squared, it starts with 5y squared, so it would be the AC method. Do we know 2 integers that multiply to be positive 15? The 5 times the 3 is positive 15, and add to be negative 16. Can anybody come up with 2 numbers that multiply to be positive 15 and add up to negative 16? Jack? I don't think they multiply to be negative 15. I need 2 numbers that multiply to be 15 and add to be negative 16. 3 and 8 do not multiply to 15. 15 and 1 multiply to be 15, but they add to 16. What do I need to change to make them multiply to be 15 and add to negative 16? What do the rest of you think? Are we there? So that means with this method, we rewrite minus 16y as either minus 15y minus 1 or I'm sorry, minus 15y minus 1y or minus 1y minus 15y. It does not matter which way you do that. So I'm going to do minus y minus 15y, and I'm going to keep the 5y squared and keep the plus 3, still equals 0. And now remember, we had to do the factoring by grouping. So Ethan, what's my GCF of 5y squared minus y? And then that will leave what? And then I need to look at the 15y plus 3, and I am going to try to figure out what its GCF would be. Leah, what's the GCF of those? So either plus or minus 3, I know will be my choices. I am hoping to get the same parentheses. So if I start with a plus 5y and I want to have a minus 15y, I better do a minus 3 as that GCF. And then minus 3 times minus 1 would be the plus 3, so I do get matching parentheses. So y minus 3, 5y minus 1 is going to be 0. So Emily, help me find y now. Okay, everybody give me thumbs up, thumbs down. Are we comfortable with those? That look good to everybody. Okay, this time my work says y equals. Last problem it said x equals. That means what I have found so far is that my y coordinate is either 3 or it is a fifth. Now I still go back into my equation up here. And if this y is a 3, I am looking at x minus 2 times 3 is negative 4. So x minus 6. So if I add 6 to both sides, what do I have for the x? Everybody good with x would be 2 here? So if the y is 3, the only thing x can be is 2. And then I do the same thing for my other one. Now the y is going to be a fifth. So x minus 2 times a fifth needs to be negative 4, which is negative 25ths. And so then let's see, if I add 2/5 to both sides, what will x have to be? If I have negative 25ths plus 2/5, what do I get? Cooper? If I take my negative 25ths plus 2/5, what do I have? Negative 25ths plus 2/5, negative 18/5. So again, not such nice numbers as I had before. I've got these fractions in there, but that's okay. These are my 2 points that are my solution points. Questions from anybody there? So we've done these 2 systems with substitution. One last example problem for today. And this one doesn't quite look the same because I still have just 2 variables, b and td. Just to make sure we believe it's not 2 lines, if I had x and y instead of those b's and td's, I'd be looking at xy plus 9y is 36. So because x times y, are you okay that that's not a line? Okay, help me have an idea based on the things that you know. How might we solve this system? There's more than one possible way, so let's see what ideas we can get on the table here. Nicole? Well, or describe it, even if you don't know the name, if you can. So I could add them together, and how would that help me? So it is elimination, and that would make the 9 TDs go away. Okay, other ideas. We'll keep that one in mind. We may come back and use that. Other ideas. Anybody else have an idea? Wyatt? Yeah, I could say BTD is 9TD plus 18, and then I could plug that in for the BTD up in the top one. Maybe. Substitution could get kind of messy. What would happen, and maybe we'll still come back to what Nicole suggested, what would happen if I multiplied one of them by -1? Could I make the BTDs go away? And then I just have the TDs left? Okay, so let's vote. Would we rather start by elimination as is and end up with BTDs that we're working with? How many want to do it that way? How many would rather multiply by -1 and make these go away so we just have TDs equal? It's kind of split, so I'm going to vote for the second one. I'm going to make this be a minus, this be a plus, and this be a minus, and then eliminate by putting my two rows together. So the BTDs will go away and make 0. 18TD, what's 36 minus 18? 18, so what's TD? Everybody okay there? Okay, now I'm going to erase those minus signs that I put in so I can see what my original ones were. And now I need to put TD in for both TDs in one or the other of those equations. So how many want me to use the top equation? How many want me to use the bottom equation? More hands there, so I'm going to put 1 in for both of these TDs. So I'm going to have B times 1 minus 9 times 1 is 18. So I have B minus 9 is 18. So what's B? So any questions on what we've talked about? It's still our same method, substitution and elimination, just a little bit messier. And when you get points, you have to be careful which x goes with which y and write them as ordered pairs. But otherwise, it's methods you are used to using.